All right, so we just got our x-intercepts. We need to get our y-intercept. So for the y-intercept, remember you just plug in 0 for x. So f of 0 equals negative 2 times 0 minus 3 squared plus 8. And that comes out to be negative 10 because negative 2 times 9 is negative 18 plus 8 is negative 10. So this is negative 10. All right. So now I just have to plot all this stuff on my grid because I haven't yet. Let's see. Green looks like a good color. Here's the y-intercept at negative 10. The x-intercepts are at 1 and 5. 3, 8 is right there. By the way, one thing we didn't write down, what's the axis of symmetry? And h in this case would be 3. So the axis of symmetry would be x equals 3. It would be this vertical line right here. So every point on there has its mirror image on the other side of that line. So it might be a good idea to go ahead and put the mirror image of the y-intercept on there. So remember, that line goes through here. And so the y-intercept is 3 away from the line, so I can put a point 3 away on the other side. That's its mirror image. And then I can connect these with a smooth curve. All right, let's do another one. Did you need me to go back? Okay. So what do we know? Okay, yeah, so the axis of symmetry, it's not just negative 3, though. It's got to be an equation. X equals negative 3. So yeah, the axis of symmetry is x equals negative 3. That wasn't the first thing I thought you'd tell me, but it's perfectly good. It opens upward. That's generally the first thing that people tell me. All right, so it opens upward. All right, so the vertex is negative 3, 1. So I can go ahead and plot that. Negative 3, 1 is right there. Next thing we have to look for are the x-intercepts, right? How do we do that? Set it to 0. So this would be x plus 3 squared plus 1. Follow the same process we did last time, right? Minus 1, minus 1. X plus 3 squared equals negative 1. So how's that going to work? Hello? You mean square root? So x plus 3 equals what is the square root of -1? I. And so this comes out to be 3, or dang it, -3 plus or minus I. Where's that on the x-axis? It's not. Imagine that. You know, we probably could have figured that out ahead of time, right? I mean, if this parabola opens upward and the vertex is right there, it's not going to cross the x-axis, because it's only going to go up from the vertex. So there are none. So that means we should probably get the y-intercept, and then if we can plot its mirror image, that'll probably be enough to graph this thing. So to get the y-intercept, remember we plug in 0 for x. So f of 0 equals 0 plus 3 squared plus 1. That comes out to be 10, I believe. So that'd be right there. Notice that the axis of symmetry is right here. I'll make it permanent this time instead of disappearing. So if I put the mirror image of the y-intercept, that would be over here. So now I just connect this with a smooth curve. Seem pretty doable? Good. Now, what we need to do is we need to figure out what happens if this isn't in vertex form, because I would still need to know where the vertex is. So, what about f of x equals ax squared plus bx plus c? What I can do is I can take that, and I'm going to factor the a out of this first part, the first two terms. So if I pull the a out of ax squared, I just get x squared. There's no a to pull from bx, so I divide by it. So this would be b over ax. Because think about it, if you redistribute that a, the a on the outside, the a on the bottom of the b would cancel, and I'd get what I have back again. Then what we're going to do is we're going to complete the square on that inside part. Remember, when you complete the square, you have to take half of that piece right here and square it. So this would be plus b over 2a squared. And normally we would add that to both sides, right? But it doesn't make a whole lot of sense for me to do f of x plus something. So what I'm going to do is I'm going to both add and subtract that from the same side of the equation. The only issue is when I square this out, I do have to distribute this a to it technically. So when I square this out, this would be b squared over 4a squared.
Teachers, please.
So anyway, we're going to add and subtract the same quantity from the same side. And because of this extra a out here, instead of this being over 4a squared, it's just going to be over 4a because one of the a's cancels. So minus b squared over 4a. Now the whole reason for doing that is so we can have it like this. when you complete the square, this would be x plus b over 2a, quantity squared, plus c minus b squared over 4a. Now the moral of the story is, this is supposed to look like a times x minus h squared plus k. So this piece right here is k, and this piece right here is h. So that means that the x-coordinate of the vertex is negative b over 2a. Useful little formula. Now, technically, the y-coordinate is equal to c minus b squared over 4a, but I'm telling you that no one uses that formula. And the reason why no one uses it is because if you just take the x-coordinate and plug it in, you'll get the y-coordinate. So the y-coordinate, plug in x from here. So once you plug and chug, you'll get the y-coordinate, and that'll give you the vertex. So let's do f of x equals negative x squared minus 2x plus 1. I can actually use the smaller one for this one. All right. What can you tell me about it? Give me something. You should be able to tell at least something about it. It opens downward. Because of this minus sign in front of the x squared. Now, it's not as obvious what the vertex is. We have to go find it. So to get the vertex, we use the formula. X equals negative b over 2a. So in this case, what would that look like? What's b? Well, b would be negative 2. So negative b would be positive 2. And 2, what's a? Negative 1. So this comes out to be negative 1. That's also x equals negative 1 is my axis. But to get the y-coordinate, I plug in negative 1. So this is f of negative 1. So this is negative 1 squared minus 2 times negative 1 plus 1. That comes out to be 2. So the vertex is negative 1, 2, which would be right there. I have 30 seconds. There's no way I'm going to finish this.